To power our world, we are very reliant on two important sources, oil and gas. Cars, transportation, power, electronics, almost everything we use runs on oil and natural gas. Another way to describe oil and gas is hydrocarbons, because they are made up of two elements, hydrogen and carbon. To understand how hydrocarbons formed, we need to go back millions of years ago. Imagine the species that lived, plants and animals and many different types of organisms.
Over millions of years, as these organisms died, they were buried underground. Water, wind, and geologic events deposited layers of sediments on top of these dead organisms, burying them. For example, let's say you go to the beach. You see the waves come in and come out. Over millions of years, the water movement creates many different layers of rock.
We call each of these layers of different rocks a formation, and each layer, each formation, represents millions of years of rock history.
Over time, the plant and animal matter is buried under all of this intense heat and pressure of the rock layers.
Under all this temperature and pressure, the dead plant and animal bodies turn into hydrocarbons, oil and gas. The same oil and gas we use today, the same gasoline we ultimately put into our cars. That same oil was originally dead plant and animal matter millions of years ago. Let's fast forward now to the present day. Let's say we own land and we want to see if we have hydrocarbons on our land. Well, how can we search for hydrocarbons that are so far and so deep underground? There are a lot of different techniques used to find oil and gas, including geological exploration, well logging analysis, and seismic. Seismic is one of the most interesting techniques. Scientists measure sound wave movement underground to try to figure out what types of materials the sound is traveling through. Imagine hitting the ground with a big hammer. Sound waves from the hammer will go deep underground, bounce against the different formations, and then come back to the sensors at the surface. Engineers can measure how fast or how slow these sound waves travel to see whether or not oil and gas may be underground. All of these exploration technologies can help us look for hydrocarbons underground. However, ultimately, the only way to be 100% sure that hydrocarbons exist is to actually drill a well, and that's where well drilling comes into play. We need to drill through thousands of feet of many different types of underground rocks and liquids to be able to find oil and gas. Essentially, we need to drill a really deep hole. At the end of the day, drilling a well is essentially the same idea as digging a hole in your backyard. Your goal is to dig deep and see what you can find underground. What's the difference? You are drilling much, much deeper. If we drill with a shovel, even the best hole we dug would only be about 5 feet deep. When drilling for oil and gas, modern wells can run from 1,000 to 30,000 feet underground. "30,000 feet is extremely deep in the ground. For comparison purposes, Mount Everest, the highest mountain in the world, is only 29,000 feet tall. When drilling thousands of feet underground, the world is a very different place. Extreme temperatures, extreme pressures, and other conditions make deep drilling much more difficult than digging a simple hole. You also need to drill quickly and efficiently and cannot use too much time. The drilling process is designed to dig a hole as quickly and safely as possible.
Drilling for oil and gas is all about the money. To make money off oil, it is vital to dig a hole efficiently and inexpensively.
We are basically just drilling a big hole to find oil and gas, but we are drilling very deep and we need to make money. This makes oil and gas drilling a lot more challenging, but also a lot more fun and interesting. We don't use a shovel, we use a drilling bit. We don't make a pile of dirt, we have an entire well circulating system. But always remember, at the end of the day, drilling a well is basically just digging a deep hole. The same basic ideas apply. A wide range of different processes have been developed to make the simple hole digging process much easier, more effective, and safer. Well control is one of these processes.
Nice job. You're done with this chapter. Good luck with the quiz.
The drilling bit is the most fundamental piece of drilling equipment. The bit is responsible for actually making a hole in the ground. The bit has to be made of strong material so that it can crush and cut through some very strong rocks below the Earth's surface. Rotate the drill bit by using the control or swiping over the image. Click on the pluses to learn more about different parts of the bit. To drill, the drilling bit. Rotate the drill bit by using the control or swiping over the image. Click on the pluses to learn more about different parts of the bit. To drill, the drilling bit constantly rotates downwards at a high speed to create a hole in the ground. Connected to the bit is a heavy piece of pipe called the drill collar. The heavy drill collar adds weight to the bit, letting the bit drill into the ground. As the bit rotates really quickly and drills a deeper and deeper hole, long, thin pipe, known as drill pipe, is attached to it and also lowered deep into the hole. Drill pipe is a hollow tube made of steel. Each joint, or portion, of drill pipe is typically around 30 feet long. The combination of the drill pipe, drill collar, and drilling bit is called a drill string. During drilling operations, hundreds of joints of 30-foot drill pipe are attached together and used to continue drilling deeper and deeper underground. 30 feet is really long. Drill pipe is so long that we can use as few pieces of pipe as possible to drill really far. Even with long drill pipe, it still takes hundreds of pieces of pipe to get to the bottom of the hole. Drill pipe is really long and very heavy. It would be impossible to connect the drill pipe and move it down with just human strength. That's where the Derrick comes into play. The Derrick is the really tall drilling rig tower that you see at drilling sites all over the world. The Derrick is a massive network of pulleys that pulls up each string of drill pipe so that it can be connected and sent into the hole. After drilling to a certain depth, pipe known as casing is installed in the well. Casing is larger diameter pipe that is placed into a drilled section of the well. Casing pipe surrounds the drill pipe and basically acts as the wall of the hole, separating the hole from the rocks around it. As drilling continues downwards, new casing is typically installed in increments. Casing is installed as it provides a useful barrier between the well and the natural environment around it. Casing prevents contamination of formation rocks and helps separate different pressure zones as we drill deeper into the ground. To make sure the casing stays in place, cement is used. This process of sticking the casing to the edge of the hole is known as cementing. After drilling to an initial depth, a wellhead is an important piece of equipment put into place to hold different strings of casing in the hole. The wellhead helps control well pressure and suspend the piping. One part of the wellhead is the casing head, a large piece of equipment used to hold the weight of casing strings and maintain them in place. Sealed connectors between different wellhead elements allow equipment to hold against high well pressures.
Nice job. You're done with this chapter. Good luck with the quiz.
When drilling a well, the bit rotates and digs into the ground. As this happens, if we were digging a hole, we would just make a pile next to our hole. When drilling a well, the bit rotates and digs into the ground. As this happens, the drilling bit cuts up all the rocks it burrows into. This creates little rock cuttings of many different sizes. If we were digging a hole, we would just make a pile next to our hole. When drilling, we need a more efficient solution because wells are much deeper and would create a lot more rock cuttings. Why remove cuttings? Since wells are really deep, there needs to be a way to get rid of the cuttings that pile up at the bottom of the well. If too many cuttings pile up, the well will become clogged and drilling will be a lot slower. To remove the cuttings from the well, we pump drilling fluids, more commonly known as drilling mud, to wash up the cuttings from the bottom and bring them to the surface. Drilling mud is generally a mixture of water, oil, and other substances used to make it heavier or lighter. In many ways, drilling mud is very similar to drain cleaner fluids that clean the dirt off the sides of the pipe. The use of drilling mud introduces us to the mud circulating system, the path drilling mud takes moving through the entire well. First, drilling mud is created and stored in large tanks, called mud tanks. In the mud tanks, oil and water are mixed together with special chemicals and clay to make drilling mud. Next, a powerful pump, called a mud pump, suctions the mud out of the mud tank. Next, the mud flows through other piping on the surface, including the standpipe, before being pushed down the drill pipe into the well. The standpipe is a pipe on the rig floor that lets mud travel from the mud pumps to the rest of the circulating system. The mud pump pushes the drilling mud down the drill pipe all the way to the bottom of the well and to the drill collar. At the bottom of the drill string, drilling mud flows out of the bit through small jet nozzles and reaches the bottom of the well. Try to spot the jet nozzles in this picture. At the bottom of the well, the mud mixes together with all the rock cuttings. After collecting the rock cuttings, the mud moves back upwards through an area of the well known as the annulus. The annulus is the part of the drilled hole outside of the drill pipe. All the yellow areas represent the annulus. The annulus is the part of the well between the drill pipe and the casing, or, if casing has not been set yet, between the drill pipe and the walls of the hole. The mud travels up through the annulus all the way back to the top of the hole. Here, it goes through several mud cleaning systems before being returned to the mud tanks. The purpose of the well cleaning equipment is to ready the mud to go back into the well. Well cuttings, gas, and foreign particles all need to be removed from the mud before it can be recirculated. The shale shaker is typically the first filter which removes large rocks and particles from the drilling mud. If necessary, several other filters also remove smaller rocks. After going through the shale shaker, the desander removes smaller rock particles, such as sand, that have not yet been removed. After going through the desander, mud flows into the desilter, where even smaller particles of rocks, such as silt, are removed.
Lastly, the centrifuge is the last rock filter, responsible for removing fine and ultrafine cuttings from drilling mud. The centrifuge rotates mud, causing heavier particles, that is, cuttings, to move downwards and separate.
Before finally coming back to the mud tank, the mud sometimes travels through the degasser, where any gas particles present in the mud are removed. We will discuss more about gas later on in the course.
Nice job. You're done with this chapter. Good luck with the